So for this lesson, we're going to be talking about getting the graphs of sine and cosine. We want these graphs because we can use them with the transformation method. With the transformation method, we can take a parent function like sine of theta and find any transformation that applies to it, such as a vertical transformation, a horizontal shift, or anything like that. Now the nice thing about sine and cosine is they are periodic functions that repeat over a distance of 2 pi. So as long as we know what the graph looks like over a distance of 2 pi, then we can just keep recopying it over and over and over again and get the shape of sine of theta and cosine of alpha in this case to know what the entire graph will look like over the span of its domain. Now, sine of theta, starting with that one, graphing it over 0 to 2 pi will be enough to give us that idea of its shape. And the trick here is to pick easy values. The easiest values to work with sine or cosine are the quadrantal angles. The quadrantal angles are located at the ends of the positive x-axis, positive y-axis, negative x-axis, negative y-axis, and then back to the positive x-axis. 0, pi over 2, pi, 3 pi over 2, back to 2 pi. So we're going to plug these values in. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now these can be plugged in for theta in our sine function. Sine of 0 is going to give us 0. Sine of pi over 2 is 1. Sine of pi is back to 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is back to 0. So we need to plot these 5 points, and they're going to give us a good idea of what the graph of sine of theta looks like. So we need 5 values from 0 to 2 pi. So here's 0. If we say this is 2 pi, then we cut halfway between those two. That'll be pi. Halfway between these two will be 3 pi over 2. And halfway between these two, the midpoint will be pi over 2. So at 0, we have a value of 0. At pi over 2, we have a value of 1. At pi, we have a value of 0 again. At 3 pi over 2, we have a value of negative 1. And 2 pi, we have a value of 0. And it's worth noting that this would be 2, this would be negative 2 for our graph. And the idea here is that the graph has a smooth curve to it, no pointy edges. So when we connect these dots, it's not going to be a V. It's going to be more like a U shape. Think like a parabola. It's going to flow something like this. And this is the graph of one period of sine. So if we wanted to know what the graph of one more period of sine would be, all we would do is go a distance of 2 pi to the left or right. So for instance, if we draw negative 2 pi over here to go 2 pi to the left, and redraw this exact same shape, we'll have a second period for sine. And we could just keep doing this over and over. It's infinite on its domain. So we could go all the way to negative infinity and positive infinity, but this is the general shape of sine. We can quickly do the same thing for cosine of alpha. We just plug in our points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Plugging in 0 in for alpha, we get 1. Pi over 2 gives us 0. Pi gives us negative 1. 3 pi over 2 is 0 again. And 2 pi gives us back to 1. And if we plot these points, Again, we draw out to 2 pi, split the difference, and that brings us to pi. The midpoints again, for each of these would be pi over 2 and 3 pi over 2. And now we plot 0, 1 right here. Then we have pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, comma 1. And remember, connecting this again with a curved shape is going to look something like this. And you might be thinking, wow, they look so different. But remember, if you draw one more period of cosine to the left, going to negative 2 pi, for instance, you could also go to 4 pi. But if we go to the left and redraw this exact same shape that we see here, then notice what happens in our graph if we look at just this value all the way over to this value. That shape is the exact shape we had for the initial period of sine. Cosine and sine are just horizontal shifts of one another. They might look like completely different graphs over the period 0 to 2 pi, but over the stretch of infinity, they actually have nearly the exact same graph with just a horizontal shift of pi over 2.